Okay, folks, this is question 3, the vertical projectile. This is also DBE June 2023. It's a national paper. Let's cut the chase. It says ball A is dropped from rest from the top of the building of 12.15.2 meters high. Now, guys, if you see here's block A is dropped from this building, so we know if it's dropped, its initial velocity will be 0. And we choose, since it's going down that one, we choose everything that goes down, it will be positive. Even also, it's applicable for block B, for ball B. It's applicable for ball B as well. It's not only for ball A only. Now it says after ball A has fallen 3.2 meter, a second ball has projected vertically upwards from the ground. And then it says now it says when ball A is here has traveled this distance, that is 3.2, ball B ball B was projected vertically upwards. So ball B, if it's projected vertically upwards, it has its initial velocity that is negative, because we said the down is positive, so its initial velocity is negative and we do not know. It's going upwards. And then it says after a while the two balls strikes the ground at the same time. So the motion of ball B, it will go like this, right? But it reaches the ground at the same time as ball A, right? But what we know that ball B was thrown vertically upwards when ball A traveled 3.2 meters, 3.2 meters from the height. All right. Now, what do you need to note, guys? Okay, let's go to the questions. Now, the free fall, guys, it says define free fall. So the definition of free fall, it's a motion under, it's a motion. Free fall, it's a motion. Projectile, it's an object. Free fall, it's a motion under the influence of gravitational force only, according to the exam guideline. Check the exam guideline for that. Now, 3.2.1, it says calculate the time taken for ball A to strike the ground. We wanted the time for ball A to strike the ground from there to there. We wanted the time it took. What do we have for that? It's 3.2.1. We have the displacement is positive. It's 15,2 because it's going down. It's 15,2, that is positive. And we have our gravitational acceleration is positive because we chose down as positive, because gravitational acceleration is always down. And what else do we have? We have the initial velocity, that is 0, and the final velocity when it reaches the ground, we do not know. It's positive as well. And we are looking for time. The main question, we are looking for time there. So which formula are we going to use in order to get that time? So simply it's this that says change in y is equal to vi change in t plus half a t squared. You get it from the data sheet. So now we choose downward as positive. We substitute our displacement, and the initial velocity is 0, and the time is the one that we look for, and our acceleration is positive 9.8, and the time is the one that we look for. So we'll have 15.2 is equal to half times 9.8. It's going to be 4.9 change in t squared, and then we divide by 4.9, and we divide by 4.9 both sides, and then we'll have change in t is equal to square root 15.2 divided by 4.9. So the answer there, it will be the time, it will be 1.76 seconds if you punch that in the calculator. So this is the whole time that ball A has traveled from the top of the building to the ground. Now Don't be mistaken by when they say after a while two balls strikes the ground at the same time. If ball A has taken 1.76 seconds to reach the ground, doesn't mean ball B has taken the same time because they reached the ground at the same time. Ball B was thrown vertically upwards after 3.2 meters per meters um, that ball A has traveled. Now the question, it says calculate the magnitude of velocity with ball B was projected from the ground. We wanted this velocity. It was projected from the ground and it takes this motion. So we wanted this velocity in which it was projected upwards. Now, I think the trick here, you should find the commonality between the two. What is to understand that the time that ball A has, if we can calculate the time that ball A has traveled at this 3.2 meters, it will tell us, let's say this, it was 0.5 seconds, the time it took here. So that means ball B was thrown at 0 point after 0.5 seconds. So at 0.5 seconds later. But we're given the displacement. So what we can do, we can calculate it this time. So having this time will tell us when ball B was thrown after. Okay, so that's what we're going to do first in 3.2.2. 3.2.2, we'll calculate the time. So we know the initial velocity of ball A, and we know the displacement, it's at 3.2 meters, right? And what else? We want the time there, and the acceleration, we know there it's positive 9.8 meters per second square because it's going down. This is for ball A, guys. We're calculating the time it took to reach the displacement of 3.2 meters. So so we'll use which formula for that? I think we'll use the same formula. We'll use the same formula to do that. Same formula that we've used. The change in y is equal to vi, change in t plus half a, change in t squared. So we use that formula. So the displacement is 3.2 and the initial velocity is 0, and the time there we do not know, and half, and the acceleration it's 9.8, it's positive, and change in t squared. So that's what we're going to do there. So we're going to have 3.2 in this side and 4,9 change in t squared. We divide by 4,9. We divide by 4,9 both sides, and then we'll have to put the square root there in 3.2,49. So if you punch that in the calculator, the square root of 3.2 square root of 3.2 divided by 4,9, it's going to be, the time will be 0.81 seconds. It will be 0.81 seconds. So this simply means that ball B was thrown vertically upwards at 0.81 seconds later after ball B this is ball B, guys. Ball B after ball A was thrown. I hope that makes sense. So what are we going to do in order to find the time that ball B took? Because ball B was thrown 0.81 seconds later. So and they reached the ground at the same time. So we will minus this time from the whole time that ball A has taken to the ground. It will tell us how long the ball B took. So ball B, since ball A it took 1,76 seconds, so ball B has taken was thrown at 0.81 seconds later. So in order to know what time that ball B has taken from the ground to reach back the ground again, so we'll say the time for ball B is equal to the time for ball A minus 0.81 seconds. So what is the time for ball A? The ball A, it was 1,76, and then we minus 0.81. So guys, every time when they say later, it was thrown later, you must know when it comes to times, we subtract the times. So that means ball B, when it was thrown from the ground to go back to the ground, it has taken this time, right? So now, knowing the time that it took ball A, ball B, so now we can simply calculate its initial velocity. Remember the question, it wanted its initial velocity. Guys, another thing that you need to note here, ball B was thrown like this. So its displacement, when the ball is thrown like this, it returns to the same position. That means its displacement is going to be what? 0. Its displacement will be 0, and its initial velocity, the one that we're looking for, it's going to be negative. Its final velocity will be what? Positive, because it's going up. Up is what? Is negative, and down is what? Is positive. That's why we have that. So the formula that we're going to use, we use the same formula. Change in y is equal to vi change in t plus half a change in t squared. So our displacement, as I've mentioned, is going to be 0, and it's very important when you do that the initial velocity will be what? Negative, even though you do not know it, and it's going to be negative, and the time it's going to be 0.95, the time it will take, plus half the acceleration. Guys, not because we're dealing with the ball that is moving up, so our acceleration now will change from the previous calculation. When we're calculating for ball A, no, it's going to be the same. Our acceleration will stick to that. It will be positive 9.8, and then the time at 0.95 square. And then when you do the math, you punch this in the calculator, you have 0.95 vi when you transpose this to this side. So punching that in the calculator, let me punch it quickly. So basically we have half times 9.8 times 0.95 square. So the answer will be 4,42225, and then we divide by 0.95. We divide by 0.95, and then the answer, you divide by 0.95 95. So the answer here, the v initial, it will be 4,66 meters per second. That's the velocity in which the ball it was thrown. Guys, if we did not insert this negative here, we're going to get the negative answer that tells us that the velocity is going upwards. But now, since we already inserted, we'll get the same answer, but we know it means that it's upwards because we already inserted the negative, and the velocity is going up. It's supposed to be negative. Alternatively, guys, to do this, what you can do, you can we can use the formula that says v final is equal to v initial plus at squared. So since we know here the ball, its initial velocity, something that returns, that returns to the ground or return to the starting point, its initial velocity is equivalent to its final velocity, right? It's going to be equivalent. So we're going to say the final velocity here is equal to the initial velocity. Okay, we say the final velocity, as I've mentioned here, the same velocity that the velocity that it was thrown at, it's going to reach the ground with the same velocity but in opposite direction. So the final velocity will be v initial, but the positive one, and the v initial will be negative v initial, plus the acceleration, it's 9.8, and the time, it's 0.95 square, and then we divide. Okay, so what we're going to have here, we're going to have 2v initial when you transpose that to that side. So you will have, let me punch that in the calculator. You will have 9.8 times 0.95 square. It's 8,8445, and then we divide by 2. The answer you divide by 2. So the answer you divide by 2. Why is not the same now? It says 8. Okay, 9,8. 9,8 times my, I'm restarting again. So we have 8,445, and then the answer you divide by 2. So our v initial is the same, guys. It's the same. It's going to be 4.66 meters per second, right? Okay, guys, let's go to the next question. Our next question, it says on the same system of axes, draw the position time graph to show the motion of the ball A and ball B from the instant the ball A is dropped until it reaches the ground. Take the ground as a 0 point. It says label graph A and graph B, and it's very important, guys, when it comes to the graph, things that you need to indicate. Clearly indicate the following: the starting time for each ball, the initial position for each ball, and the time for. So the graph the graph here in 3.3, it's going to be graph like that. It's going to be graph like that. Remember, guys, we have chosen, this is change in y and the change in t in second. Remember, we have chosen down as positive, so that means our graph will be down. So guys, we'll draw our graph here. So if we've chosen up as positive, our graph we're going to be here. So what are we going to do now? The bow A, it started from the height of 15.2. So here's our 15.2, and it goes to the ground. It goes like this, and it reaches the ground. And how long did it take? It took 1.76 seconds. And this is what? This is bow A. Now let's draw for a bow B. Bow B, it starts from the ground, guys. This is the ground, right? This bow A, it starts from the height to the ground. So for bow B, it starts from the ground, but how long did it start? It starts later. Which is, it didn't start here at 0. It started at this point. At the time, it was 0.81 seconds. If you still remember, it starts 0.81 seconds later, and it moves up, up, and it reaches the ground at the same time, like this. It reaches the ground at the same time there at 0.76, but it started later at 0.76. Our graph will be like that, guys.